for question 3, you are given an insertion sort in ascending order. So ascending meaning that it's going to sort in an increasing order, so from smallest to the largest one. Now what the algorithm does here is actually very similar to what we covered in class. So firstly, it's going to look at whether the array has size 1 or lower. If it is size 1, then it's already sorted, right? You cannot sort an array of size 1 because there is only one element. You just return it immediately. How about this one? What does it do then? So this one is going to go for the remainder of the array. So for example, let's take a look at an example array. So let's say if it is 21, 23, 17, 19, let's say 15. Let's say we try to sort this. So then the I is going to go from 1 to the length of the list. So it's going to start from 1, which is this one. So I is now pointing at this one. And then they start with something else which is called position, and it's going to start at the same value. So then what we are going to do is to compare it to the one that is on the left. Well, in this case, position is greater than 0, and the value that we have, which is the current value, is less than the one that is in the previous position, which is the one before. Then we are going to move the position. But in this case, there is no movement, right? Because there is no problem here. So then it's going to go on to the next I. Now the next I is going to go to this one. So this is I now. And again, we start with P pointing to the same place. So while position is greater than 0 and the value is less than list position minus 1, so that means what we are doing is to compare the value here with this position, which is 23. So this is smaller, so then we're going to move the position to the previous one. And we keep going, and we are going to go on to the next position. So 17 compared to 21, 17 is smaller, so the position P is going to go to this one. So now position P is no longer greater than 0, we stop, right? So what does it mean? It means that we are actually searching for where is the right place to put the number currently at I, which is now at 17, right? And we find that the right place to do that is P. How do we discover that? Because we just keep going to the left and compare. As long as it's smaller, we keep moving the pointer P. Now at some point, we find the right location. We now have to move this 17 all the way to P. So how do we do that? So for I, as long as it's greater than the position P, then we are going to swap it, right? So that means I is going to take on the value of I minus 1. So we move this to this one. We move this to this one. And then finally, we insert 17 to where this is supposed to be. So this is what the insertion sort is doing. So each time, we are just going to compare it to the left, find the correct position. Once we find the correct position, then we just need to move all the other elements to make up space for this element in the right position. Then we just insert it there. This is essentially the insertion sort. Now it's currently going in the ascending order, and we want to modify it so that it goes in descending order. So descending now means that it needs to be decreasing. So then what can we do to do this? What are some of the possible strategies? In what ways can we turn a sorting algorithm that is ascending into descending? You push. How do you push the biggest number to the left?
So instead of smaller, it should be bigger than the one on the left.
Which one? This one? This one?
Yeah.
Okay, alright. So this is the most straightforward one. In fact, the best possible, the best one possibly, is to do this, but instead of smaller than. Right, so with just this one change, you will turn it from ascending to descending. Essentially what we are saying is that it's still ascending, except that we are changing the meaning of what it means to be bigger. So bigger is now smaller. It means that you're just changing the meaning of the comparison. And other than that, everything else can remain the same. Now if this is a case, then your best case and your worst case will change, right? Your best case now is when it's already descending. And your worst case is when it's still ascending. Now another possibility is that you keep things as usual. So run everything first, sort it first, and at the end of the day, reverse the outcome. So it means that at the end, just before you return the array, just create another array that reads from right to left, and then it will essentially be doing the same thing. Now, if that is the case, I mean, in theory, the complexity is the same, but in actual runtime, you need to spend one more step of reversing the order. Now, in this case, then the best case will be when it's still ascending, which is still the same as the original one. And this case is descending is the worst. Right. Essentially, these are some of the major strategies. Now, if you really want to, you can rewrite it such that you don't move things to the left, you move the smaller things to the right. That could also be done, but it will require a more major change to the algorithm.